I think this is week 6 or so. So next 2 weeks or thereabout is going to round up. So I'm not going to proceed with data visualization. Let me explain. If there is any issue, I believe you could have reached out. You could have reached out earlier in the group. So I'm only going. Today I'm going to explain the concept in machine learning generally, so you know what we're talking about and how machine learning tasks are being done. Right. So let me share my screen. By now, what I'm expecting of you people, you should already know how to write Python codes. You should already know how to use pandas, because we'll be using it heavily. So you should also already know how to use what's it called? Seaborn or Matplotlib. Which one? Anyone you were taught there? Which one were you taught? Please, I need a response. So I can
Absolutely.
Matplotlib.
Matplotlib. Okay. So at least you should have done bar charts, all these charts, at least if not 2 or 3 charts there. So I don't want to beat around on something you have done. We don't have enough time with us. So machine learning. We define machine learning as the ability of a computer to learn from data generally, right? Um, it has been on for several days. If many of you have known spam filter before, a spam filter is a kind of is kind of algorithm that helps you to remove spam from your emails. Spams are unwanted messages. We do receive them most of the time in our mails. Trying to share my screens because so it's just giving me some. Okay. So if you are to do a spam filter with basic Python code, we are going to be setting several rules, right? And for instance, if you check your spam, you notice that there are some common messages that are in those emails. Like go through them, you will see them. So that is how your email is able to classify them as a spam email, right? But we don't want to do that traditionally. We want to let a computer learn from data on its own and be able to dictate if a particular email is a spam or not. So I believe you can see my screen now. So can define machine learning as an act, right? As an act of programming so that the computer can learn from the data. Author Samuel also defined machine learning as a study that gives the computer the ability to learn without telling them or without explicitly programming them. So just let your computer reason on its own. That's where artificial intelligence comes from. So Tom Michel also gave some cumbersome definition, like computer is said to learn from experience E with respect to task T and some performance task P. All these are just grammar anyway. So machine learning is the ability to learn from data. And I've given an example, an email flagger that can flag whether an email is spam or not, right? So I'll explain this sometime, not quite long. That we can see some things like for you free in our email, right? We can, if you try to add code all this, you just say if for you in email, if credit card in email, if so you can imagine the long rows that we are going to have. Wow. And one thing about it is that you can't beat a fraudster like that. Let's assume that people have noticed that all their mails get blocked, right? All their mails get blocked. And they notice, okay, what if instead of we use for you, we use we use another we use another like um, um, FOU. You know, it is readable, even though it's not that the message is not that clear, but it's readable. We know FOU, it means for you. So by that, your code will not be able to detect that mail as an as a spam, right? So another thing we can do with machine learning, probably we have something that we want to detect a pattern for, right? Want to detect a pattern from it, and you just can't do it traditionally with Python or any other language. You have to use machine learning. Right? So the next thing, you want to test or repeat a program until it is good. So you keep testing and testing. So you need to actually use machine learning algorithm for that. So to summarize, problem for which machine learning exists requires a lot of hand-tuning or a long list. Now, don't get it twisted. Some people, some tasks that you can do basically by just writing Python code, you want to use machine learning to solve it. That's not that's not what we are saying. You don't use machine learning by fire by force. You get, if once basic thing can do that, you can write code and solve. No, you can just let it go. But once you have kind of tuning or long list of rules, the machine learning might be the best for you to use. Next thing is, once your problem is complex, right? Your program is complex. For example, you want to detect the voice notes, right? You can't really base it on hard rules because people can have different pitch. Let's say I'm talking in a very noisy environment, right? If you have to code that, you will just notice that my pitch is going higher, higher. So you just have to use the machine learning that can auto detect all these solutions that cannot be solved with complex, with traditional, programming. So let's go talk about types of machine learning. I know you'll be wondering, machine learning, what is it? How do we use it? So we have different types of machine learning, right? We can classify machine learning based on how it is supervised. You want to talk about um, supervised or unsupervised or semi-supervised or reinforcement. All this kind of, they were trying to determine what type based on, does it need human supervision, and to what extent is the human supervision. And under human supervision, we have supervised learning, unsupervised learning, semi-supervised, and reinforcement learning. Another way to classify machine learning system is that, can they learn on the fly, as in, can they learn instantly as they are seeing the data? Or you have to first of all train them for a while, then put them to production. So in that case, we have two types. We have online learning and we have batch learning. Are we together? So the next is, we can classify machine learning system based on, can they learn data from point to point, or they're just going to predict some models and however you want to do it. So anyhow, these are the types of ways. In fact, there are many ways you can classify machine learning, but the most used is the human supervision, which is supervised, unsupervised, semi-supervised, and reinforcement learning, right? So let's talk about supervised learning. So when we say a machine learning system is supervised, we're talking about the length of supervision we are giving it, and there are four major categories. Are we together? For supervised learning, it means that we are trying to um, build a model or a machine learning system whereby we tell it what we are predicting and what we are using to predict. For instance, I want to predict um, whether an image. Okay, since I'm working, okay, I want to predict whether an image is an apple or not. I want to predict whether an image is an apple or not. So what I need to do, right, is to give it the apple. So I say, once you see this, it is called an apple. Once you see this image, it's called an apple. So there are two columns in that data you are going to feed in. The first thing is the feature, which is the image. Then the second is the name. Is it apple or not apple? So in that case, you are trying to give it what you are predicting and what you are using to predict. That might feel too ambiguous. Let me give another example. Let me say we want to predict, okay, the price of the house. There are some factors that affect the prices of the house. Let's say the size of the house, as well the location of the house, right? The size of the house and the location of the house. So then, so in our data, we are going to have size of house, location of house, and then price. Do you get? So in that case, you are giving the system what the result is and what are we going to see before we can say it is this result. Do you understand? In that case, that's why it is supervised. Sometimes you might call it, people might call it labeled data. Labeled means you are giving it the target. Are we together? Label. So in that case, our label is the price. The target is the size. I mean, the features are the size and the location. That is that is just what make people call it supervised. So supervised learning is when you are giving your model all the data, the features, and what you are trying to target, what you are trying to predict. That is supervised learning. Supervised learning can be of two types. Right? Supervised learning can be either classification or regression. Are we together? Now, I've given an example of both actually. I've given an example of both actually. Now, the example I gave for classification was, is it an apple? Is it not an apple? So that's a classification problem. Now, the example I gave for regression is that predicting the price of the house, right? So that is a regression problem. So I can simply say classification is predicting a discrete values, right? It can be more than one. For instance, apple is one, apple is just two, apple not apple in that instance. But it can be, is it apple, is it beans, is it rice, is it whatever, whatever, whatever. Do you get? But it must be discrete. That's classification, supervised classification machine learning system. It can be regression. An example I gave was the housing price. Now, housing price contains a price can be a continuous data. So we can say regression is predicting continuous value as our target, right? Price can be any value, can be 10, can be 100, can be 1 million. So that is supervised regression problem, right? Question so far before we proceed. At least I'm badly dehydrated here. I am. Come up. Hello, poor quality network. Am I still on? Hello, can you hear me?
You are.
Okay. So, some example of supervised learning, supervised learning algorithm. There are many, anyways. But some few of them are we have here. We have um, K nearest neighbor. K nearest neighbor is basically used for classification. You can use it for regression anyway. You can use it for regression. So we have KN neighbors. Linear regression, strictly for regression. Logistic regression, we can use it for both classification and regression. SVM, support vector machine, can also use this for classification and regression. Decision tree, it's basically for classification anyway, but can be used for regression problems. Right. So now let's go to unsupervised. Then unsupervised learning. And unsupervised learning. We're not going to give it our targets. Right. We're only going to give it the features. Let's say we want to predict the price. Now you are going to remove the price. You want to predict the price of the house. You're going to remove the price column and just tell it all the features and let the computer predict the price on its own. Are we together? That is an unsupervised learning. So we can say an unsupervised learning. We give the algorithm an unlabeled data set. We give it an unlabeled data set. Are we together? So, and some are the examples of unsupervised learning. We have clustering algorithm. Some algorithms are just used to cluster, right? We have k-means algorithm, we have DB-scan, we have hierarchical cluster analysis. We also have some unsupervised that are used to detect anomalies. Maybe you want to see some things that are not supposed to be like that. An example of such algorithm, we have one class support vector machine, isolation forest, and so on. We can send you these notes so you can read on that. Now, let's say you have a data that you collected from your blog site, right, from your blog, and you want to know the group of these blogs so that you can know how to strategize your marketing or your whatever you're blogging about. So what you need to do is you can use cluster to find connection between the data. You might notice that 40% of your visitors are males and they love reading certain type of book, maybe comics, and generally 20% are young, they love scientific uh, things. So all these things can be detected using unsupervised learning algorithm. So we also have semi-supervised, right? In a semi-supervised learning, it's like combination of supervised and unsupervised. We are very used to such example. Let's say many of us have used Google Photo before. In a Google Photo, the um, the algorithm will give you one image and tells you who is this, who is in this image. Are you the one in this image? If you are the one, right, that means you have given the algorithm one label. That is, you tell it the answer that this is me. Oh. Now, by itself, the algorithm will now classify every other picture of you, and classify it together. That is unsupervised. Is it together? Are we together? So that means the computer is doing two things: supervised, unsupervised. So in that case, that is a semi-supervised learning. So yeah, supervising it halfway, you're not supervising it full way, right? So that is semi-supervised. We also have reinforcement learning. Now, reinforcement learning is similar, it's just your robotics programming, right? Now, in this case, the robot itself is the agent, right? The agent who is going to observe its environment and take some actions. For instance, you are having a robotic car that can move on its own, or self-driving car that can move on its own without having accidents. The environment in which your car is driving is the environment, right? While the car itself is the agent. It's going to perform some actions in the environment. That's good. Now, it's going to be rewarding itself, right? If well, if it did not have any accidents, it's going to reward itself. If it has accidents, it's going to penalize itself, right? So it's going to give itself penalties and rewards. As accidents, retracting, doing right? A policy is defined as a kind of actions that the model. Sorry, just let me call you back. I beg. Judge and paper that you go. Then let's go. Yeah, I see the office. Apologies for that. Sorry. So um, so a policy can be defined as all the actions your model have finally decided to take after it has gone through ups and downs, giving penalties and also giving rewards, right? So so all these concepts are very, very important before we actually go on to. I will skip instance-based learning, model-based learning. Okay, let me just explain. So, and I'll round up there. So, now, in so far, maybe we should quickly recap. Say machine learning is the ability to learn from data, right? And we say we have um, about 4 types of machine learning algorithm. We have human supervision, model-based, or instance-based. We also have what's it called? We also have um, what's it called again? Is what's the name again? Also, whether it can learn from data point or it can create a model. So that is. So let's quickly talk about instance based versus model based. The ability of a model, the ability of a model to the ability of a model to be able to predict is known as generalization. For instance, you go to Abuja, you took a car, right? You took a taxi. Now, how the driver react to you is going to affect your experience, right? You can either decide that, oh, all taxi drivers in Abuja are good, or all taxi driver in Abuja are bad. What are you trying to do? You are trying to generalize. So generalize is a term in machine learning, right? It means it is predicting on some data points we have not seen. Are we together? So now, if in an instance-based model, in an instance-based machine learning, it's not going to be learning by heart. It's just trying to say, okay, once I see this, this is it. Once I see this, this is it. So that's an instance-based machine learning. Now, a model-based machine learning is a kind of, okay, let me give this example. Let's say you want to predict whether humans are happy or not, right? Whether humans are happy or not. We can get the data from OECD website, and we can get our GDP data also from IMF website. You can merge them together. Then from there, you can now use to decide whether our features. Okay, let's make it interactive here. Let me stop this screen because this is the last thing we're going to talk about. Then stop. Um, just a minute. But before you can, while I'm opening my file, you can drop your message, your question if you have. You can drop your question if you have one. Okay, I think everyone is a guru in machine learning now. Since nobody has a question, okay, I'll just wait for my file to load and then I'll display that. Having it on now. So let's you might decide you might be interested in PDF I'm using. I'm using hands-on machine learning by Let me take you to the beginning of the note. So this is note. Hands-on machine learning with scikit-learn Keras. This is one of the book I learned with anyway. So the base and life satisfaction. The higher their GDP, right? The higher the life satisfaction. So let's see. We plot a scatter plot. I believe we should have just scatter plots with parallel. You have something like notice that the higher the satisfaction, if you notice, and the thing is going upward trends, then we can then create a function like this. Now, this might look kind of ambiguous. I know, I'm sure you've done linear equation before. The equation of a linear, the equation given as y equals to x plus c, mx plus c, which is m is your gradient, x is your data point, and c is your slope, right? In this case here, data scientists make use of theta, but that does not make that one wrong anyway, just a convention. So your theta 1 here is your intercept. Your theta 2 here is your gradient. So your theta 0 here is your intercept. Your theta 1 here is your slope. And your theta 1, your GDP per capita here is the x, the data. Are we together? So in this case here, this is a model. This is what they call model. Are we together? This is just a model. So this model is what your algorithm will be using to calculate, right? So this is just a linear model here, and you can see it gives it gives a straight line, kind of something, right? So you can just plug in whatever data you want. Where they plug it in. So look at this now. Let's say the intercept is 4.85. The GDP per capita is 22,580, and your intercept, I mean your gradient is this. So your GDP per capita will give you this. So this is just a way to calculate. So this is a lineage, just a model. That's what they call model view, using function or formulas to calculate whatever you want to calculate. So that's just it. So let me just give you I told you this is just an introductory class to machine learning. Then we will give better or more advancements on this. But just let's get to this. Plus, please, I need your response this time around. I need your response, please. You can all unmute yourself. So now, by now, you should know what this line does. What is this line used for? Hello? There's no, I think the meeting is over then. Hello? Hello?
Hello.
Did you get the message I passed? No problem.
No, I couldn't really. I didn't get it.
So that means that many of us are not. It's not fair. So let's pay attention here. That's why I
The
keep on. There should be
audio is like
response.
cracking. That's why.
Okay. So what is this line doing here? This particular line. I believe you can you see my screen?
Yeah, I can see it.
So this particular line here, what is it for?
Is it the one I
By
like?
now we should. They are not like the yes.
Yeah, you imported Matplot
Matplot.
for data
What is it?
visualization.
What for data visualization? That's what I just wanted to get used to the libraries we use for data science. What about this one,
Okay,
NumPy?
okay.
Did we take NumPy? Okay, we did not
Yeah,
take
yeah, yeah.
NumPy because
We
of
didn't
time.
take it. We did
So,
pandas, yes.
you did it in pandas, okay. You did NumPy. Now this is only the
Yes.
library you are not used to. Now to do machine learning, they said now scikit becomes one of the most popular library to use for machine learning. Now, if you want to import it, we say sklearn, sklearn,
Okay.
scikit-learn. So from sklearn, we are importing linear model. So this is the only library that you are not used to in all this. But
Okay,
you know
okay.
what this line does. You should know what this line does. What does this line do?
We are like importing the file, basically reading
Thank
the
you.
file you want to.
Very correct. We are reading the file. We use
Yeah.
pandas to read the file. Now, in this case, our data set is in two different files.
Okay.
The OECD, and
Yeah.
this contains
Okay. The
a function is not
OECD
shown
and
here.
the GDP.
Yes, that contains your the life satisfaction data. Right. Why this
Okay.
contains the GDP per capita. Right. Then
Okay.
there's a function that is not shown here. It is used to concatenate. So we merge these two data sets together. How do we, right? That will go to give you all the function. I believe we learned function when we're treating
Yeah.
Python. Okay, good. So we do that, then we use NumPy to get this. We use NumPy to get this. Now, things I need to explain as the machine data into two. Source target, right? Data scientists, machine learning engineers usually use capital letter X as your features, right? And they use small letter y as the target. You might also hear them say, our X is our matrix and our Y is our vector. That's also a common thing they will say. Or they say feature matrix, target vector. So anyhow you see it. So they split it like that. So this is your features and this is your. Now what is the features? The features are going to use to predict what we what we are predicting is our target. In this case, we are predicting life satisfaction. What are we using to predict life satisfaction? We are using GDP per capita. Are we together? So
Yeah.
everybody
Well,
should know what this line does. What does this line do?
is to visualize the data.
Thank you. What kind of plot are we using?
Scatter.
Scatter plot. Did you guys treat scatter plot the last time?
I was only in the last class.
Okay, so we are using scatter plot in this case. That's what I say. Every lesson is a prerequisite for the next one. It is very, very important.
Yeah. I'll
So this
go
is
through the videos.
people might so this people might not be aware of. So in this case here, we instantiate our model. Okay, we did not talk about classes or object-oriented programming language. Okay, but there's no problem. We create some we want version. So what we have done here is that we have created a model. Are we together? So we have created a model in this case. Now, see this line here, model.fit. Now, the model is going to train in this place. We pass our training data set, our features X and our targets Y. We pass it there. So your model will train here. It's going to learn from all model dot to what? The model. Now this is the new feature. Let's assume that we want to predict the life satisfaction of CPOS. CPOS is a country, right? our data does not have a country called the data of it. So we want to predict it. Uh, the GDP per capita. So this is the GDP per capita here, right? Which is 20,587. So all I need to do is to do model.predict your GDP, and it's going to output 5.96 as our satisfaction. Overview of what my start machine learning. So from next class, then we're talking about in-depth, how to do some in-depth in some concept like.
Sorry, please.
Yes, go ahead.
This dot predict, is it a method?
Thank you. It's a method. It's a method
Okay.
this scikit-learn linear model.
Okay.
So that's just it. It's not a big deal. You can see half of what we have seen, half of the code are what we have seen before, up to this place. And the model training, model prediction, model that predicts for our model prediction here. So I don't know if there's question. If there's none, I need to round up and end the class. Questions?
I don't have any question.
Okay, network is bad. Blessing Adams, apologize. Sorry for that. My network too is doing somehow. So let's end the class. I think I have some other things. Thank you. Then we proceed
Okay.
from where I stopped.
Can we
next
get
class.
this text?
Yes, you can. Definitely. I'll share it to the group.
Okay. Thank you very much.
All right. Have a nice day.
And you too.